When we talk about measuring temperature in buildings, most people think of a standard thermometer. But in building science and thermal comfort analysis, temperature isn't just one number. It's a combination of different heat exchanges happening around the body. To understand these different heat exchanges, we used 3 key measurement tools. 1. Dry bulb temperature. 2. Wet bulb temperature. And 3. Black globe temperature. Each one measures a different aspect of the environment, and together they help us understand how hot a space actually feels, not just how hot it is. In this video, we'll break down what each of these measurements captures, how they are used, and why they matter for comfort, design, and indoor environmental quality. At the end, we'll also show a simple summary overview which you can reference at a later time. Dry bulb temperature is the most familiar measurement. It represents the temperature of the air itself, measured by a standard thermometer that is shielded from radiation and moisture. This is the value you see on thermostats and weather forecasts. It's the baseline we use for HVAC control and general thermal conditions. However, dry bulb temperature alone does not tell the full story of thermal comfort. A room can have an acceptable air temperature and still feel uncomfortable due to humidity, air movement, or radiation from surfaces. So we need more information, and that's where the next measurements come in. Wet bulb temperature measures how temperature and humidity interact. It is taken with a thermometer that is wrapped in a moist cloth. As water evaporates from the cloth, it cools the thermometer. The more evaporation that occurs, the lower the reading becomes. This makes wet bulb temperature a direct indicator of humidity and evaporative cooling potential. In other words, if the wet bulb temperature is close to the dry bulb temperature, the air is humid. If the wet bulb temperature is much lower, the air is dry. Building on that idea, wet bulb depression, or WBD, clarifies the relationship further by measuring the numerical difference between the dry bulb temperature and the wet bulb temperature, showing how much cooling is possible through evaporation. Wet bulb temperature helps us understand how effectively the human body can cool itself through sweating. This is especially important in warm climates, high humidity environments, and spaces where physical activity is happening. Black globe temperature is measured using a thermometer inside a matte black sphere. This setup is designed to absorb radiant energy from the environment. Black globe temperature measures how warm the space feels due to radiant heat from surrounding surfaces and sunlight. This is directly influenced by factors such as solar gain through glazing, warm walls, floors and ceilings, nearby heat sources, and radiant asymmetry in a room. Black globe temperature is essential for evaluating comfort in sunlit interior spaces, locations near large glass facades, industrial or equipment-heavy environments, and outdoor or semi-outdoor spaces. It is also a key component in comfort indices like WBGT, which is the wet bulb globe temperature, often used in occupational health. Each bulb type measures something different. A dry bulb measures the air temperature, a wet bulb measures the humidity and evaporative cooling, and the black globe measures thermal radiation from surroundings. When combined, they provide a more complete understanding of how people actually experience temperature. This is fundamental for designing comfortable buildings, planning natural ventilation strategies, avoiding overheating risks, and managing indoor air quality, and moisture behavior. A single temperature reading can't tell us everything, but by using dry bulb, wet bulb, and black globe measurements together, we can bridge the gap between physics and human perception. If you found this video helpful, give it a like, and if you want to dive deeper into building physics and comfort, subscribe to this channel. Stay informed, stay inspired. TimberTalk.